So this first one is from last year's trial exam. And what you guys will see and what you would have seen now is that with most things, we start off with the grade 11 work and then we move into the matric work. Analytical geometry is no different. We start with the grade 11 concepts, your basic midpoint, gradient, distance, angle of inclination, and then we move into the circle questions, equations of a circle, distances, etc., etc. Okay, so the bulk, once again, in analytical is the grade 11 stuff. So again, so important to revise. I don't have it here, but I know in my lessons I always say one of the sections to revise is analytical geometry from grade 11. Alrighty, so let's have a look. Now, guys, remember with geometry as well as analytical geometry, so Euclidean and analytical, we need to read that information in the beginning of our question carefully. I've also made the mistake, as many of us do, of jumping straight into the question. So I just ignore that whole paragraph and I jump straight to write down the coordinates of t. If we look at that, that is a 1-mark question. And looking at t, I can start to see, okay, cool, it's a y-intercept, etc., etc. But the information that I'm going to need is in the information for the question. So always make sure you read your information so that you know exactly what you're working with. Because often there's little hints and clues in there of what is potentially going to be helpful to us as we answer our questions. So it says in the diagram below, D, 4, 5, R, negative 2, 2, T and S form a quadrilateral. So they haven't told us, sorry, I second-guessed English as a language here for a second. They haven't told us what quadrilateral, but we do know it's a quadrilateral. RD cuts the y-axis at N, and T is a point on the y-axis. Ooh, sorry, there we go. And T is a point on the y-axis. The inclinations of RT and TS are alpha and theta respectively. RD is parallel to TS, so we know that one pair of opposite sides are parallel, so at the bare minimum we know this is a trapezium. And the equation of TS is y is equal to a half x minus 2. Okay, so immediately, again, looking at my first question, I've got some information there that's going to be quite useful for me in answering my question. Now, guys, remember we've had this conversation. If you want to draw on your diagrams, highlight on your diagrams, color in on your diagrams, you do whatever you want to do on your diagrams to help you answer the question. All right, so this equation over here relates to this line over here. And then we were also told that we have parallel lines. Okay, for me, I'm very much a visual learner. I like to be able to see things on my diagram. So I do personally like to highlight, color in, do what I need to do. You obviously don't have to do that. Okay, it's completely up to you. But I know just for myself, especially in geometry, it really helps me see what I need to see. Okay, so the first question, like I say, is write down the coordinates of point T. Because we have this equation of our line TS, we immediately know what that coordinate is. This negative 2 is our y-intercept. T is very clearly our y-intercept, so we know that this is at 0, negative 2. So literally no thought required, 0, negative 2, 1 mark. Sorry, my cat's are having a time. 1 mark, we're done. I've said this before, so you know this. I like to fill in information on my diagram as I go along. So I've put the coordinate there for T. I have it. I can now use it. Right, 3.2, and this is now where we generally start to do the whole grade 11 content sort of thing. We now start to ask you the basics, gradient, distance, midpoint, all of those things. Okay, I just want to take my diagram and just move it so that we can actually still see it and use it. Okay, there we go. Right. So the first question says, calculate the gradient of RT. So RT, this line over here, fairly straightforward, substituted into my gradient formula. Now remember, guys, all of these formulas are on your formula sheet. Analytical is actually a really nice section in terms of formulas because everything that we use in analytical is actually on our formula sheet. So gradient formula, y2 minus y1 over x2 minus x1, change in y over change in x. Okay, you've been using this since grade 9. So this is a formula that should be very familiar to you. And then we just substitute in. Remember, it doesn't matter which point is 0.1 and which point is 0.2. It makes absolutely no difference. I'm going to use this as 0.2 and this is 0.1. If you did it the other way around, it's absolutely fine. So m equals the y-coordinate of 0.2 is 2 minus the y-coordinate of 0.1 is negative 2. Be careful of your signs. There is going to be a sign change there. Again, like I know I'm talking about like a very small sample, noticing that a lot of things that are going wrong are just really sign issues in this grade 12 trial paper. Right, x of coordinate 2, negative 2 minus x of coordinate 1, 0. So in my numerator, I've got a positive 4. My denominator, I've got a negative 2, which means my gradient is negative 2. And if you look at the line, that makes sense. My line is decreasing from left to right. It should be a negative gradient. I mean, these diagrams aren't drawn to scale, but it is relatively steep. I wouldn't use that as too much of an indication. More look at, is it decreasing? Yes, it is. So a negative gradient makes sense. 3.2.2 asks us for the size of angle RTS. Now, the second they mention an angle, we're going to have to think about our angles of inclination. And so we're going to have to, oh my God. Sorry, everyone. It was just chaos. My cat jumped up. Tea went flying. Okay. It's okay. Anyways, so once we have an angle of inclination type of question, we're going to have to think of our angles of inclination. Okay, I'm going to have to do a bit of multitasking here, but it's all right. So when we think of our angles of inclination, one of the things we need to look out for in our diagrams are triangles. Okay, what you're going to start to see is that the triangles or the shapes that sort of form in our diagram is going to sort of lead us to how we're going to get our missing angle. So when I say look out for triangles, I'm talking about the fact that in a triangle, we have a whole bunch of different reasons that we can use to work out an angle. So for example, we've got sum of angles in a triangle. We've got exterior angles of a triangle. And we have all of these geometry reasons that we can use to work out missing angles. So this is what we want to look out for when we are sort of dealing with these types of questions. All right. Okay, sorry. Had to do a bit of multitasking there. So as we have a look at this, and apparently we've got 2Q1 there. First, let's identify where RTS is. So RTS is this angle down here. Now, obviously, where possible, it'd be great if that was just an angle of inclination of one of our lines. Unfortunately, it's not. It's an angle created between two of my straight lines. So now we have to go back to our actual angles of inclination. Now, in the information of our question, I told you what the angles of inclination were. So the angle of inclination of the line TS is this angle theta, and the angle of inclination of the line RT is this angle alpha. Now, I've told you about those angles. They're obviously important. And hopefully what you can start to see is as I've sort of added in those bits of information, we can see that we have a triangle created with my x-axis and point T. I don't know if you can see that triangle very well. Let's maybe just highlight it. So here's the triangle. Okay. And all of these angles sort of deal with or are part of my triangle. This angle theta, if I use vertically opposite angles, I get this interior angle of my triangle. What that then means, I've got an exterior angle. I've got an exterior angle of a triangle. I have the two opposite interior angles. I can very easily go work out what RTS is. So that's what I was saying earlier. Look out for triangles, your angles of inclination that you've been given or that you can go and work out. and use that information as you go along. All right, so I know I need to work out theta, I know I need to work out alpha, and then I can use my exterior angle of a triangle to work out the rest. Exterior angle of a triangle is not the only way you could do it. Obviously, you could use angles on a straight line to then get this angle adjacent to alpha, and then you could use sum of angles in a triangle. That's absolutely fine. It's whatever you see. But look out for triangles. And when in doubt, just start working out angles of inclination. Somewhere along the line, one of those is going to be right and one of them is going to be useful. At least you can get part marks. So it doesn't really matter which angle you start with. We've just worked out the gradient of RT. So I'm going to work out alpha first. So tan alpha is equal to -2. Now remember, to get alpha, we will have to say shift tan of -2 on our calculator. And that gives me -63,434, and that's a whole long decimal. Now remember, that negative is considering the acute angle. We are looking at the obtuse angle here. So if we add 180 degrees, we will get the obtuse angle alpha. So if you go to alpha here, the angle we've worked out is this angle over here. That is the -63,43. And by adding the 180, we're essentially using angles on a straight line to go and get the alpha size. So that's why we add 180. All right, I'm not just adding 180 willy-nilly. There is a reason. And so we get alpha is equal to 116,565. Again, there's a whole long decimal. We should try and keep these decimals because this isn't my final answer, and I should only round off from my final answer. Obviously, if you don't, it's not the end of the world, but we shouldn't round off until we get our final answer. Right, then I'm going to go look for theta. So angle of inclination of the line TS. Remember, TS has the equation y equals a half x minus 2, which means this half is my gradient. So tan of theta is equal to a half, and this is why, again, it's so important to read the information in your question, because if we hadn't read that information, I wouldn't know what my gradient is, and I would then panic because I don't know how to work out the gradient if I don't have the point S. Shift tan a half, we get theta is equal to 26,565. Again, a whole bunch of decimals. So now that we have all of these pieces of information, we can now go and work out what RTS is. And remember, we said RTS, we're going to use exterior angle of a triangle. So I'm going to say alpha minus theta, because remember this angle here is also theta, in order to get my missing angle RTS. Now this angle, we don't really have a label here. So yeah, bit problematic. You could add a label, I suppose. So you could say, let's say that's angle X. So angle X is also equal to 26,565 because of vertically opposite angles. And so RTS is equal to 116,565 minus 26,565, etc., etc., etc. My reason, exterior angles of a triangle. And so we get that RTS is equal to 90 degrees. Right. This is obviously not the only way that you could do this question. There are other ways that you could do this question. So it's up to you, okay? But when we're giving you angles of inclination, try and use them as far as possible. Okay, like I said, not the only way to do this question, but it probably is the most straightforward, easiest way to do the question. Again, when you are working with angles of inclination, look out for triangles. 80 to 90% of the time, it's going to be some sort of triangle reason. Trying to think of an example where I've seen one where it hasn't been a triangle reason. It's usually a triangle reason. And when in doubt, just start working out angles of inclination. At some point, you'll probably get what you need, and then you can go from there. And even if you don't, this is a question worth 5 marks. You can get part marks somewhere. All right. So let us take a screenshot because it's going to start getting quite small. So let's take a screenshot at this point. and then we will carry on. All right. Okay, again, I'm just going to move our picture down so that we have it. Right, so 3.3 says determine the equation of RD in the form y equals mx plus c. So RD is obviously one of our straight lines, and RD is this line up here. Now remember, one of the important pieces of information we were told is that RD is parallel to TS. So that piece of information immediately helps me, because if RD is parallel to TS, that means the gradient of RD is equal to the gradient of TS. And so immediately we already know y is equal to a half x plus c. We already know the gradient because the gradient of TS was equal to a half. From there, it's just a simple case of substituting in a point. We have R and we have D, and it doesn't matter which point you substitute in because they're both on the straight line. I'm going to substitute in D, but again, it makes absolutely no difference. And the only reason I'm substituting in D is because they're both positive. And so 5 is equal to a half times 4 plus C. A half times 4 is 2. So 5 equals 2 plus C. Move this. Which means that C is equal to 3. And so therefore y is equal to a half x plus 3. And what that means is that, okay, my arrow is the wrong way. What that means is that I actually now know the coordinate of n. This is the y-intercept, and so n is at 0, 3. So if they had asked me, or if I needed later on, I do have that coordinate there. So again, guys, reading your information, so important, because it often gives you a whole bunch of clues that you can then use in answering your question. Right, 3.4 says if RT is parallel to DS. Okay, now remember, we have already been told that RD is parallel to TS. So we've already been told that those orange lines are parallel. Now we're being told that RT is parallel to DS. Now we've got two pairs of opposite opposite sides parallel, sure. And so that means that RDST is a parallelogram. Sorry, I panicked. I forgot how to spell parallelogram there. So that bit of information is helping me. It's telling me it's a parallelogram, and so that means I can now use properties of a parallelogram. So if RT is parallel to DS, calculate the coordinates of M, the midpoint of RS. So if we look at where RS is a diagonal. Here it is. And what we need to remember is that diagonals of a parallelogram bisect each other. What that means is they cut each other in half, and so therefore they have the same midpoint. Now that's useful to me because, yes, it says M, the midpoint of RS, but we have the coordinates of R, but we don't have the coordinates of S. So that's a bit of a problem. I can't work out the midpoint. However, I've got the coordinates of T and I've got the coordinates of D, which means that I can go and work out the midpoint of TD, and its midpoint is going to be exactly the same as the midpoint of RS. So knowing your properties of your parallelograms and just quadrilaterals in general is super important, because we use them especially in analytical geometry. Okay, so like I said, let's just rewrite this. RDST is a parallelogram. And we know this because both pairs of opposite sides are parallel. And because it's a parallelogram, we therefore know that the midpoint of RS is equal to the midpoint of TD. And that's exactly what I said earlier. Our diagonals of a parallelogram bisect each other. So what we can do is we can go and work out the midpoint of TD. Now remember, your midpoint formula is the one where it's two fractions. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. We're working out the halfway point. This is the formula that's really nice because you can actually work with these separately. So when you're looking for a coordinate, particularly of a parallelogram, oftentimes we use the midpoint formula because of the fact that you can separate those fractions, or you can separate your coordinates and work with x and work with y. Okay, so the midpoint of TD, you can put it in whatever order you want. 4 plus 0 over 2, 5 minus 2 over 2, and so we get that our midpoint of TD, which is exactly the same as our midpoint of RS, which is M essentially, is equal to 2 and 3 over 2. And we've calculated the coordinates of M. So again, guys, knowing your properties of your parallelogram, of your quadrilaterals, very, very useful, very, very important for the section. Okay, without it, we are going to struggle to be able to calculate these sorts of questions. All right. I think we've screenshotted all of that. So let's do this question, then we can screenshot. Right, 3.5 says calculate the area of a triangle RTN. Okay, so rather than working with that somewhat chaotic diagram, let's just put a diagram here for ourselves. So the area of RTN, again, there's a few ways that you can answer this question. It's going to be completely up to you. So here's triangle RTN. Not my best triangle I've ever drawn in my life, but whatever. Now, remember, we already know that n is at 0, 3. And that's kind of all the information we have about our triangle right now. Now, again, so I'm so sorry. There are so many different ways that we can go and answer this. And so it's going to be very much up to you how you choose to do it. So I'm going to talk you through some of them, but I'm going to show you the way I did it just because I think it's the easiest. It requires the least amount of working out. Now, we've already worked out that this angle over here, RTS, is 90 degrees. Those two orange lines are parallel, which means that that angle over there is also 90 degrees. And so what you have is a right angle triangle. So you could go and work out the length of Rn. You could work out the length of RT using your distance formula. Half base times height, you have the area of your triangle. Okay, so that's one way you could do it. If you really felt that way inclined, you could use the area rule from 2D trig. Go for it. Nothing wrong with that. But this is how I did it. And personally, I think it's the least working out, but it also, it's completely up to you. Right, so what I saw was that this vertex here at R would be my height. So if I then drew a perpendicular line down to, if this is my base, the distance from the y-axis to R would be my height. And the distance from my y-axis to R is 2 units. Okay, that x-coordinate gives me the distance. So I know my height. I know that the distance from n, which is at 0, 3, down to t, which is at 0, negative 2, is 5 units because vertical distance. And so I'm just going to do half base times height. All right, so the height is equal to 2 units. My base, nt, is equal to 5 units. And so my area is equal to half base times height, which gives me 5 units squared. And that's it. So again, I'm saying this is how I saw it. It's not necessarily how you see it. It's not necessarily the only way to do it. There are definitely other ways that you could answer this question. I just saw it immediately like that. And so the only working out you actually needed to do here was for the triangles area. But obviously, again, like I say, you can work out the length of Rn, you can work out the length of RT, and because you know that that angle nRT is a right angle, again, you can use half base times height. You could use trig, the area rule. There are so many different options, and it's completely up to you and also what you sort of see in your diagram first. So again, that's how I did it, but so many different ways that you could. Right, so I think we're here in terms of screenshots. Whoops. Okay, there we go. Let's take a screenshot of that first question. So hopefully, guys, what you can see is it's really not too tricky. Nothing here was overly complicated. I would say maybe the angle of inclination question might throw us off, and this area question often throws us off. I don't know why, for whatever reason, whenever we throw in an area, it sort of panics us, but it shouldn't, okay? It's you have all the information and you have all the tools that you need in order to answer these types of questions. Right, so that's your first grade 11, grade 10 analytical geometry type question. And then we get into the grade 12 sort of level question. And this is now where a circle is often involved in our situation. So question 4 says, in the diagram below, a circle centered at M, PQ touches the x-axis at S, and the line OA is a tangent to the circle at N, -6, 8. Okay, so a couple important things. This is our point of contact between our circle and the tangents at N and S. And remember, if you go and have a look at your two tangents, the length of OS to ON, those will be exactly the same because they are tangents from a common point, O. Also, another thing to remember is the fact that from your point of contact with your tangent to your center, that forms a right angle, tan, perp, rad. If you can hear my cat crying, please just ignore him. He's having a bit of a moment in life. And because those are both radii, they would also be equal to each other. So immediately, just by us being told that we have tangents, we have a whole bunch more information than what is initially visible to us, for lack of a better description. Okay, so that's what we have. We have that line AB. We don't really know what it is just yet, but we have it. So we'll deal with it in a second. The first question asks us to calculate the length of ON. Okay, so ON is essentially this length over here in pink. Now remember, O is your origin, 0, 0. You have two coordinates. All we need to do there is substitute it into our distance formula. We haven't actually used our distance formula yet. So distance equals, this is my worst formula. I can never remember it properly. X2 minus x1 squared plus y2 minus y1 squared. If you go x1 minus x2, it doesn't matter. Okay, it makes absolutely no difference. So this is our distance formula. Again, all on your formula sheet. You don't actually need to memorize it or anything like that. Okay, just going to put that up there because that makes a lot more sense, doesn't it? Right, so our distance of ON is equal to the square root of, you can start with whichever coordinates you want, makes no difference. I'm going to start at the origin, so 0 minus 6 squared plus 0 plus 8 squared. So remember, minus -8 would become plus 8. I was a bit excessive in my straight line there of the root, but whatever. And then you just type that into your calculator. At this level in grade 12, I do not need to see that you can do individual working out step by step. That's not something I need to see. You just chuck that straight into your calculator and you get an answer, and that answer is 10 units. Now remember, because we know that this line ON is 10 units, we also know that this line OS is 10 units. Cool. That's done. Literally no other thinking required of me. Let's just move these up for us. Whoops. 4.1.2 asks us for the value of P. So let's just identify where P is. P is the X coordinate of my center. Okay, now this is going to be quite useful, this information that I've just found. And remember, guys, oftentimes in questions like this, where it's 4.1.1, 4.1.2, I'm leading you into something. So P is my X coordinate. As I've just said to you, or as I said earlier, this line MS is going to be perpendicular to the x-axis. So basically, MS is a vertical line, which means that whatever this x-coordinate at M is going to be exactly the same x-coordinate at S. And then obviously, because S is on the x-axis, the y-coordinate is 0. So if I can figure out how far away S is from the origin, I have my coordinate. And we have just worked that out. Okay, so we have just worked out what our length is. So we actually know that our x-coordinate is 10. So obviously we need to write a whole bunch of stuff down. So first of all, we know that ON is equal to OS. And I said this earlier because of tangents from a common point. And so that therefore means that OS is also equal to 10 units. It's exactly what I just said once we finish that question, which therefore means that P is equal to positive 10. It's on my positive x-axis, so it's 10 units to the right of my origin. And so immediately I know that M is at 10 and some Q value. So I know what P is. I have that information. That's it. All right. So using the information you've been given and what you've worked out, we need to use everything in conjunction. 4.1.3 says the gradient of NM. Now I'm going to ask you to do this one yourself, but I'm going to just talk you through it a little bit to help you out. So the gradient of NM. NM is one of our radii. So here it is, NM. And remember, we said that NM is going to be perpendicular to ON. Now, the problem is for the gradient, I don't know what this Q value is. So it's not like I can go straight away and work out this gradient of NM. But I can work out the gradient of ON and use the fact that it's perpendicular to work out the gradient of NM. So I want you guys to give that a try for me. You can pop your answers in the chat. Let's see what we come up with. Use the fact that they're perpendicular to help you here. I'm not running away from you. I'm just running to get a tissue, and I don't think you need to see that chaos of me mute sneezing again. Okay, obviously if you've got questions as you go along, just ask. I'll give you another minute or two. Like I said, pop your answer in the chat. Nice, Awami. Okay, let's have a look. If you're not done, don't stress. That's absolutely fine. So obviously, guys, the first thing that we said was that ON is perpendicular to NM because of tan per grad. Now, remember, these are geometry reasons, so we do need to give them. So please remember to do that. And so what we can do is we can work out the gradient of ON. So gradient of ON, we've got 0 minus negative 8 over 0 minus positive 6, which gives us negative 4 over 3. Now remember the rule with, I'm going to say parallel. The rule with perpendicular lines is that when you take the gradient of one line and you multiply it by the gradient of another line, you should get negative 1 as your product. That is for perpendicular lines. Parallel lines, as we've already spoken about, they have the same gradient. So we can use this fact to now go and work out our gradient of MN. If I take negative 4 over 3 and I times it by our gradient of NM, I must get negative 1, which means that my gradient of NM is equal to positive 3 over 4. Now, you don't need to show this step over here with a little star. That's not necessary. The trick is that you take your gradient that you have. So we would take our 4 over 3. You change the sign. So it's negative 4 over 3. It becomes positive. And you flip the fraction. So instead of 4 over 3, it becomes 3 over 4. And we get our gradient of our line that's perpendicular. And that's it. All right. So again, using the knowledge that we have about the geometry of a circle and its tangents to help us answer this question. Excuse me. Right, 4.1.4 asks for the value of Q. So Q, remember, is our y coordinate of our center. And again, think about the fact that you have just done a whole bunch of questions, gotten a whole bunch of answers, see how it helps you. Okay, now, if we could somehow figure out how far down the y-axis Q is, that would be great. Similar to how we worked out P, that would be awesome. But we can see that there's no real coordinate that sort of lines up with that. That's a bit of a problem. We don't know the distance of our radius, so we don't necessarily know how long our radius is, so that's not going to help us. The center of your circle is the midpoint of your diameter. We don't have a diameter, so that's not going to help us. The only thing that really is going to help us is the fact that we've just worked out the gradient. So we have just worked out the fact that our gradient of MN is 3 over 4. Okay, so this gradient over here is 3 over 4. And so if we now were to go and set up an equation using the coordinates of N and M, I can go and calculate my unknown Q. So 3 over 4 the gradient that I know is equal to NM is equal to y2, so Q minus y1, negative 8, over x2, we've worked out P, it's 10, minus x1, which is 6. And so we can set up an equation using the gradient we've just found to go and work out what Q is. So 3 over 4 is equal to Q plus 8 over 4. Both of those denominators are the same, so you could multiply them away, leaving you with 3 equals Q plus 8. And so that means Q is equal to negative 5. Now, again, this makes sense. It's in the negative quadrant or the negative y values. It makes sense that this should be negative 5. And now we have our center coordinates. Right, so this one, I will be honest, stumped me a little bit because, I don't know, my brain did not automatically go to, oh, use the gradient, you've just found that. But sort of use, I don't know, deductive reasoning, sort of as we talked through it. What information do you have? What formulas do you have that you could use? If none of them are going to work, we sort of can narrow it down to the point where something does work for us. So I ruled out midpoint, I ruled out distance, I ruled out being able to read off the value like we did with S. The only other option was gradient. Okay, so like I said, this wasn't a hard question. I think it just stumped me initially because it wasn't something I initially thought to do. All right, so let's take a screenshot of those questions so far, and then we'll move into 4.2. Just obviously give you the questions, because that would obviously be super helpful for you to be able to screenshot. All right, there we go. Right, now you can sort of think we've kind of done a few nice grade 11 type, you know, gradient, distance, all of those fun things. A little bit harder than question 3, absolutely. But now we're going to lead into the circle stuff. So you can pretty much guarantee that from 4.2 onwards, we're going to be talking about characteristics of our circle. All right, and there we go. Obviously, I have so much space now. Let's just move these up. And then again, I'm just going to put our diagram here so that we don't have to scroll up and down and you can see it. All right, there we go. So the first question says, determine the equation of the circle in the form x minus a squared plus y minus b squared equals r squared. This is great. I have all of this information. I know where my center is, so that's wonderful. Technically, I know what my radius is because remember, we spoke about the fact that this line from S to M is a vertical line. If M is 5 units down from my x-axis, that means my radius is 5 units long. So r squared would be 25. So I actually have all of the information that I need. So MS, which is our radius, is equal to 5 units. And so when I now get the center, my equation rather, I've got x minus 10 squared plus y plus 5 squared is equal to 25. Now guys, just remember, much like when we move left and right with our algebraic functions, the signs in these brackets are the opposite of what the coordinate is. So the coordinate for m is positive 10, negative 5. When we substitute it into my equation, it's negative 10, positive 5. Obviously, when you substitute in with that negative sign in front of the a and b, it works out. But just bear that in mind that it's counterintuitive. Okay. So now I have my circle equation. Lovely. Right, this is now where we start to panic, and we had this discussion when we did the algebraic functions. Anytime we see this value k, we think, nope, I can't do this. This is too hard, especially because it often involves nature of roots and stuff like that. And really, it isn't hard. Okay, we just have to think carefully about what it's saying to us. So this question is saying, x equals k is a tangent to the circle. Write down the value or values of k. Yes, sorry, the value or values of k. Right now, again, don't panic. This is not something we need to panic about. Let's just break down what this question actually means. Sorry, my child has decided to sit on my lap, and now I have to move back to make him space. X equals k. Now remember, k is always going to be some constant. We don't know what the constant is, but it's going to be a constant. So x equals 1, x equals -3, etc., etc. And we know that when we have a line x equals a constant, I'm working with a vertical line. Okay? That's what I'm working with. Simple as that. So a vertical line, when we're talking about tangents, will either be, and let's maybe make this a bit thicker so it's quite clear, will either be here on the left-hand side of my circle, so there's a tangent, or it will be on the opposite side, right-hand side of my circle. I will move it so that it's a tangent now. I'm fully aware of the fact that that is not a tangent. Right. Those are the two possibilities I have here. These are both x equals k, because they're both vertical lines. And now I just need to figure out what that k value would be. Now remember, we know what the radius is. So we know that from M to that point of contact with that tangent would be 5 units, and the same on the other side, that would be 5 units. If M is sitting at 10 on my x-axis, 5 units to the left would be at +5. 5 units to the right would be at +15. That's my values of k. That's it. That's all I have to do. So either k is equal to 5 or k is equal to 15. And so again, grade 12s, don't let these types of questions scare you. It's understanding what the question is asking. That is the biggest part of the whole scenario. But once you know what it's asking you, it's so nice and easy. Okay, especially when it's a vertical or horizontal line. Okay, just because I am this person. Look at that. Look at that. Absolute baby. Anyways. Alrighty. So that's all it is. Vertical line. Think about where those tangents sit and you sort it. Right. I've seen quite a few of these questions in 4.4. So it's quite a nice question that we get to do here. When I say I've seen a few of them, like in a few past papers that I've had a look at, I've seen it crop up quite a bit. So nice that we're getting to have a look. So it says the line of y equals -4/3x plus t cuts the circle at 2 different points. Okay, so this is now where, again, our knowledge of circle terminology comes in. If a line cuts our circle 2 different points, we have a situation like this. Okay, there's point 1, point 2. This is called a secant. A line that touches our circle once is a tangent. A line that touches our circumference and doesn't go beyond the bounds of our circle is called a chord. Okay, it's not something you need to stress about right now. We need to stress about the secant situation that I've drawn. Okay, I've also drawn it with the wrong gradient, but you get the picture. Okay. Determine the values of t. So let's go back to where t is. Y equals -4/3x plus t. This is a straight line. And even more importantly, this -4/3 should be ringing a bell. We've seen this -4/3 somewhere. Now we know that that represents a gradient of our straight line. And if we go back to what we've sort of already worked out, look at that. There is -4/3. That was my gradient of ON. So if I go and have a look, this gradient over here was -4/3. Right, so now we need to think about what this means. That line currently is a tangent to my circle. Okay, we know it's a tangent. We were told it's a tangent. We know it's a tangent. It's currently only touching my circle once. And so essentially what this means is I need to take this line. Again, I should have made this slightly thicker. So let's do that. Just that we can see what's happening. Okay, so I need to take this line. We're just going to extend it so we can work with it. And I need to figure out where should I move it so that it remains parallel because it still has the same gradient. How do I move this line so that it cuts my circle twice? Now, if you look at how I'm moving this line, it's going to cut my circle twice all the way until it reaches the other end of my circle where it becomes a tangent and then doesn't intersect anymore. So I need to work basically within this range for this line. And I need to figure out all my different values of t where this line can exist so that it remains parallel but cuts my circle twice. And like I said, we're eventually going to need to move it and keep it within the domain from one end of our circle to the other. So that's what this question is essentially saying to us. Again, once we understand what the question's saying, it becomes so much easier. So let's have a look at how we would go and deal with all of that. Let's just not work with such an excessively thick pen. So like we said, because our gradient is equal to -4/3, we're working with a line parallel to ON. And that's what I've just shown you there with my beautiful diagram. Now, hopefully we can all agree that my t values need to sort of be within the range from the point of intersection with N and whatever the point of intersection on the other side of my circle is. And that's what we discussed now. It has to fall within that range. So I'm going to call this point of intersection, you can call it whatever you want. I'm going to call this point of intersection X. So let X be the coordinate opposite N. Again, you can call it whatever you want. I'm just going to call it X. And we essentially want to go and work out what that coordinate is, because then I've got a defined range. Now, again, let's think about what this is. If we were to go opposite N all the way to X, it would go through my center point and it would actually create a diameter. So I can use the coordinates of M to work out what that other coordinate is. I can use my midpoint formula to go and work out what X should be. So I know that my center is at 10, -5. And I know that I can now use my midpoint formula to work it out. So what I mean by that is I have an X coordinate plus 6/2 and the Y coordinate of X minus 8/2. I can now go solve for X and Y. This is the beauty of the midpoint formula. So the beauty of the midpoint formula is I can now work with them separately. So the X coordinate, X plus 6/2 must be equal to 10. And in a similar fashion, the Y minus 8/2 must be equal to my Y coordinate of -5. And I can solve for X and Y. So times both sides by 2 for X, I get X plus 6 equals 20. And so X is equal to 14. For Y, times both sides by 2, Y minus 8 is equal to -10. Add 8 on both sides, Y is equal to -2. So that coordinate X is at 14, -2. And so now I've got that defined sort of domain range or sort of interval, that's the right word, I knew like my brain would get there, a defined interval for which this line can exist. Now, we are being asked for the value of t. T is your y-intercept. So I've just worked out the coordinate that would sit on the line that could extend furthest along my circle. I still need to work out where its y-intercept would be. But that's easy. Now I just substitute it into my formula. Y equals -4/x plus t. I'm going to substitute in my coordinate x. So -2 equals -4. I don't know what on earth that is. This is not a hyperbola. So let's fix that situation. -4/3x. There we go. So -2 equals -4/3 times 14 plus t. And I can now solve for t. And we get t is equal to, it's not a very nice number, unfortunately, 50/3. And so we know that the y-intercept of this line down here is at 0, 0. The y-intercept of that line up there will be at 50/3. And so t must be somewhere between those two values in order for my secant to exist. So again, as long as t cuts my y-axis above 0, but less than 50/3, I'm going to have a secant in my circle. And that is essentially how we would go and deal with this question. Again, I know this is not necessarily an easy question. Again, it takes a visualization of what it is that we're actually asking you to do here. But understanding the question is half your battle won. Okay, so again, I don't think it's a particularly hard question, but I do think that we need to understand what has been asked of us. And sometimes that is a bit tricky, particularly in analytical geometry, where we can throw some curveballs at you. But so I'm just going to let you take a screenshot. Guys, please, if you have questions, ask. All right? If it makes sense, that's great. But if you do have questions, please ask. Do not cause chaos. I'm talking to my cat. I apologize. This is chaos. Okay. Right, we've got one more question. I just hadn't moved it up. Right, there we go. So it says another circle with equation x minus 10 squared plus y minus 6 squared equals 25 is given. Will the two circles touch, cut, or not? Give a reason for your answer. Okay, so again, I'd really like to not have all of this chaos happening. So I'm just, okay, apparently not. Oh no. Let's just put our diagram here for ourselves. Okay, there we go. So remember, we've already worked out the equation of the circle. So we know that this is at x minus 10 squared plus y plus 5 squared equals 25. Sorry, I don't know why I panicked with that. That is our equation of our circle. And now we're being given this equation. So we now need to be able to compare these two equations and figure out what's happening, how are they different, what's the situation. Okay, so if we consider the circle that has been given to us, this another circle, let's just establish where it would sit. So here we have a center at 10 positive 6, and we still have a radius of 5 units. Okay, so let's think about this. If my center is at 10, 6, it's not going to be a great diagram, but we're just going to roll with it. Okay, so let's say, yeah, 10, 6. And I have a radius of 5 units. Hopefully what you can agree with me is the fact that the distance from my x-axis all the way up to my center is 6 units. But because my radius is only 5 units, that radius would stop short of my x-axis. That's a terrible circle. But anyways, we move. Let's just center it maybe. Yeah, there we go. It's a bit better. So this radius here is 5 units. Yes, it's 6 units from my x-axis to my center, but the radius is only 5 units. And so what that means is that this other circle is never actually going to get anywhere close to the x-axis. If we then compare it to the circle we're given, this circle intersects with the x-axis at x. And so based on that fact, based on the fact that this circle is going to sit somewhere down here, these circles are never going to touch. It's not possible because of the fact that my radius has remained the same, and my circle is actually, if we compare the centers, which is at 10, -5, this other circle has actually shifted too far up to intersect. This has shifted 11 units up to now be at a center of 10, 6. And so because of that shift, it's not going to intersect with each other. Right, so so many different ways you can reason this. Essentially, you can say your new circle has shifted 11 units up. Which means that, this is probably not the most mathematical term, but your bottom limit of your circle will stop at y equals 1. So remember, it will stop here at y equals 1 because of the radius. Therefore, it won't intersect. And guys, in questions like this, I mean, like for me, I would have to do a visual diagram of this whole situation. That's fine. As long as you then just like sort of write a little explanation of what you've done, drawing a diagram for yourself as part of your explanation is absolutely fine. That is part of your reason. Like I say, just write a little sort of statement so that your marker knows what's what. But there's absolutely nothing wrong with you drawing a picture to help yourself. Again, I would not have been able to answer this question if I hadn't drawn the picture and I hadn't gone and visualized what was happening. So if that's what you need to do, absolutely feel free to do it. Okay, we do often like to ask you questions of, here's a new circle, is it going to intersect, touch, fall inside, what it would? Okay, I do have a nice summary of that somewhere, and that is, I need to find it, of how you can tell whether or not circles are going to intersect with each other, whether one circle will sit inside another or whatever. Like I said, I've got a summary somewhere. I just need to find it, and I will put it up on the Google Classroom for you. I know there was another summary I said I would put up now as well. I can't remember, but I'll figure it out. Something to do with stats, correlation. Okay. It's been a week. I need the term to end, and then I can do all of these things and give it the appropriate amount of energy it deserves. Yeah. I'm getting to a point now where I might have to lock a child out. I don't know. We had like a fire drill thing today, and we've got, I'm sure your schools are the same. We've got different drills for different situations. So like a fire drill, a bomb alert, a hold fast, etc. So we had a hold fast today, and hold fast is where you have to stay in your classroom with your children. And I was with my grade 10s. Lovely children, love my grade 10s. However, we ended up sitting in that classroom, I think, for about an hour and a half. I don't know what was going on with the drill, but an hour and a half. And it got to a point where I was like, okay, bye-bye. Don't come back. We've loved each other for 90 minutes and we can we can see each other tomorrow. Yeah, it was crazy. So I'm ready for the end of term, as I'm sure you guys are as well. All right. Hope we've got our screenshots. I think we've got time for another. Let's see which one we want to do. Okay. We'll just carry on. All right. So let's have a look. In the diagram, P, R at 3, 5, S at negative 3, 7, and T at negative 5K are the vertices of a trapezium, PRST, and PT is parallel to RS. RS and PR cut the y-axis at D and C05 respectively. PT and RS cut the x-axis at E and F respectively, and PEF is equal to theta. Right, couple of things. Unlike the last question we did, this question tells you this is a trapezium. Now, unfortunately, a trapezium is not, I mean, it's special in its own right, but it's not really special in that it's got a lot of unique characteristics. A trapezium, really the only unique characteristic or useful characteristic is the fact that it has two pairs of opposite parallel sides, which has already been given to us. So we know which sides are parallel. We can't really do much more than that, but we do know it's a trapezium, and so that's nice. The next thing that I want you guys to notice is that you were given the coordinates of C and R. Who can tell me what they notice about those coordinates? Is something the same? Is something different? What do we notice? Nice, Owami. Okay, so Owami said the y value is the same. Owami, what does that mean about the line? Good. Okay, so they're on the same line. Yeah, absolutely, Layla. It's a straight line. Anything more specific? What type of straight line? If the y value is the same? Okay, all of these are perfectly correct. Not what I'm looking for, but perfectly correct. So collinear, same gradient, absolutely. All along the line PCR, we will have the same gradient, absolutely. What I was looking for is it's a horizontal line. Okay, so when our y value is constant, this is a horizontal line. Now, the reason I'm pointing this out is because that obviously means that P will have a y coordinate of 5. Ah, nice, Layla. Exactly. It's parallel to the x-axis, so it's a horizontal line. Excellent. So if we have to go and work out the coordinates of P, or if we need that at some point, we already know the y coordinate because of the fact that it sits on this horizontal line. Oh, excuse me. And the fact that, as you guys have all said, those points P, C, and R are collinear. They fall on the same line. Okay, that's really the only sort of bit of information I can take from that. Let's have a look at the questions. Oh, these children. Right, so the first question says, write down the equation of PR. Look at that. So PR is this horizontal line we've just spoken about. If you think about horizontal asymptotes, it's always y equals. And so this is just y equals, excuse me, y equals positive 5. That's it. Nothing more, nothing more than that. Okay, that is my equation. Got it. My children are being very neat. But anyways, we move. Okay. Obviously, again, I've made some choices here, so let's maybe move these up for ourselves. Yes, my sweet baby. I know. I know your bum's a little bit in the way, but it's okay. All right, let's have a look. Again, look at this chaos. She's on the desk with us. On the desk. Lovely. Anywho. Okay. Yes, my dear. Okay, now you're staring straight at my cat's face. Okay. Clearly, we are all here ready for the end of the term. Anywho, okay, let's have a look. So, calculate the gradient of RS. I feel pretty confident that you guys can do that. And I feel pretty confident that you guys could work out the size of theta. So I'm going to ask you to do both of those questions for me. I'll give you 5 minutes for both of them. 5 marks, 5 minutes. And then we'll have a look. Obviously, guys, if you've got questions as you go along, just ask. You can put your answers in the chat. Just let me know if you need help. Okay, guys, let's have a look. If you're not done, again, don't stress. You can just work with me as we go along. So the gradient of RS, nice and easy. We have those two coordinates. So this would be, and again, remember, it doesn't matter which is your y2 and your y1. It's up to you. 5 minus -7 over, over, it didn't really get better. My sweet girl, stop it. 3 minus -3. So I always like to subtract the negative just because it makes a positive sign. Like, it really makes no difference. It's completely up to you. All right, we then have, stop it. We then have, I have to now hold her here so she doesn't chew the pen. Anyways, 5 plus 7 is 12 divided by 6, which gives us a gradient of 2. Nice and easy, no fuss, no muss, all done. Right, the size of theta. Now this one's actually quite nice and easy because theta is an angle of inclination of TP. Okay, obviously that's not a straight line, but whatever. It's an angle of inclination of TP. Now, yes, we don't have P's coordinates. However, we know that TP is parallel to SR. And because we've just worked out the gradient of RS or SR, whatever, it's the same angle of inclination. This angle here will also be theta. So we don't need to stress about anything. They're the same angle of inclination because the gradients are the same. So the gradient of TP is equal to the gradient of RS because we were told that PT is parallel to RS. And so we can say tan theta is equal to 2. So theta is equal to shift tan of 2. You don't really have to write that tan -1 thing. You can just write the answer. I'm just reminding you that we would use shift tan, which is 63,43. Okay, and so we have theta. This was quite a nice angle of inclination question, very easy. It wasn't like that last one where we had to find the triangles and use geometry and all of that. What this was testing here was the fact that you knew that parallel lines had the same gradient. Right, 3.2.3 says write down the coordinates of D. So D would be our y-intercept of the straight line SR. And so we would then need to go and work out the equation, essentially. Now, again, nice and easy. I know what the gradient of SR is. So I know y is equal to 2x plus c. Substitute in one of those points. I'm going to substitute in r. So 5 is equal to 2 times 3 plus c, which means that c is equal to -1. And so D would then be at 0, -1. Right, so again, just think about what all of these points are, y-intercepts, x-intercepts, parallel to, etc., etc., and you can easily get your answers from there. Okay, so let's screenshot that, and then we'll move on to the next set of questions. Okay. And obviously, you know, I've done it again. I nearly made a joke there, but I think you guys are all too young to understand. I was going to say I'm like Brittany, but I don't think you guys know Brittany's oops, I did it again vibe. But if you do, you can laugh along with me. Okay, let us see what we have here. So it says, if it is given that TS is equal to 2√5, calculate the value of K. Right, this is a nice question in the sense that it's very easy to make a mistake, but it is a very easy question to answer. All right, so I just want to move this a little bit up. I know we're now sort of overlapping a little bit, but it's okay. All right, so it's telling us TS. TS is this over here. So we've been given a length. Because we've been given a length, we're going to have to use the distance formula. I don't like the distance formula. It's a formula that I constantly get wrong, but it's on the formula sheet, so don't stress about it. So we know that it's equal to 2√5. and that would be equal to square root. Actually, do it like this. Square root, I'll fill in the root thing now, the lid of the root, and we subtract the x values. Yes, so -5 minus -3, so +3. I'm sorry if you can hear the wind, it's crazy here in Western Cape at the moment. Plus k minus -7, so +7. All right, so I've got all of that. It's great. The reason I'm saying this is an easy question, but often a question that we get wrong, is because it's easy. We substitute into the formula, we solve the equation. Why we often get it wrong is because we're solving for a quadratic. Okay, this is a quadratic equation that we're going to end up with. And so we need to be very careful of what our inverse operations are going to be. I'm about to have a third cat on this table, so chaos. Right, first things first, I want to get rid of that square root. I don't really want to have to deal with the square root. Where possible, get rid of that nonsense. So I'm going to square both sides. Now, you can just type that into your calculator, but 2 squared is 4. Root 5 squared is 5. 4 times 5 is 20. Again, type it into your calculator. There is no need for you to try and do that in your head. Right, we're getting rid of the square root, so that's gone. This bracket, -5 plus, -5 plus 3 is -2. -2 squared is 4. And then we're going to have to distribute out this bracket. So this becomes k squared plus 14k plus 49. And this is where the quadratic comes in. Okay, this is now a quadratic equation. So that means I need to make one side equal to 0. I've got k squared plus 14k. 4 plus 49 gives us 53, but then we have to subtract 20. So that gives us plus 33. And now we go and factorize. Now remember, grade 12s, you can use the formula. If you aren't super comfortable with factorizing by hand, just use the formula. There's no need to panic. This is quite an easy factorization. So this would be k plus 11, k plus 3. And so we get that k is either equal to -11 or k is equal to -3. Now we need to decide which one that is. Now look at your diagram. Look at the position of coordinate t. It definitely can't be -11 because S has a y coordinate of -7. -11 is below that. It can't be that. So we cross that one out and we say k is equal to -3. Now again, this is like a really silly thing. However, when marking, so in when we mark your exams and finals, if you do not eliminate the option that doesn't apply, you will lose a mark. So either you've got two options. Option 1 is you eliminate it. My suggestion is to do so. Give both of the solutions, eliminate the one that doesn't apply. Option 2 is to just not write down the second solution. Okay, so either you have to have crossed it out or you need to not have it at all. Okay, so if you could see from your solutions that it has to be -3, you could have just left that out completely and then it's absolutely fine. However, I personally prefer to write down both of my solutions and then just cross out the one that doesn't make sense. If you think of like your surd equations, you would do that method anyways. But please, guys, if you haven't eliminated one of the options, what that means is you're going to lose a mark. There's literally a mark allocated on the memo for saying not equal to. So again, it seems like such a silly thing, but please make sure you do actually eliminate the answer, because otherwise you're going to lose a mark. And that's a really, 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 really silly reason to go and lose a mark.